All right, so in this example, we've got two possible answers. It could be that they're both right. It could be that neither one is right. It could be one is right and one is wrong. So we're going to check both of them, and we're going to start by substituting. Now, you're probably not going to have a whole lot of space on your paper to do it side by side like I'm going to do it, so you might have to do one on top and one on the bottom. But for each one, what we want to do is plug in the 6 anywhere we see the C. So we've got 5 times C. So 5 times 6 plus 7 equals C squared, so that'll be 6 squared plus 1. And then we need to simplify it. And remember, we need to do each side on its own. So we don't need to worry about doing the same thing to both sides of the equation. We just want to simplify each side. So let's start with the left side. On the left side, we have multiplication, we have addition. Which one should we do first? Multiplication. What's 5 times 6? 30. So we get 30 plus 7, and 30 plus 7 is? 37. On the right side, we have an exponent and we have addition. Which one of those should we do first? Exponent. What's 6 squared? 6 times 6, which is 36 plus 1, and 36 plus 1 is 37. So what does that mean? That means that 6 is a solution to this equation, right? So we're going to put a check mark there. All right, for the other one, we want to see if negative 6 is a solution. So it's going to look exactly the same, except we're going to put a negative 6 in wherever we see a C, not a positive 6. So it's going to look something like this now. And just like the last one, we want to simplify each side. So on the left side, we'll do our multiplication first. 5 times negative 6 is? Negative 30. Okay. So we have negative 30 plus 7. And negative 30 plus 7 is? Negative 23. All right. On the right side, we have negative 6 squared, which is? What's negative 6 times negative 6? Positive 36, right? So we've got positive 36 plus 1, which is 37. Is this a solution? No, this is not a solution, so we're going to put an X through it. And again, we don't have to go back and figure out what the correct solution was. There should be 2 answers to this because we have a squared here. We know what one of them is. We don't know how to find the other one yet, so we're not going to worry about that. Right now, we just want to say, yes, it's right, or no, it's wrong, and that's it. This is just like the one we did in the opener today. In fact, we did this one in the opener yesterday. So I'm going to just go through it really quickly, and we'll find our solution, and then we want to check our solution. All right, so I'm going to go through this real fast. Circle a variable, box the square root because we want to get that by itself, draw the line of equality. Then to get the square root by itself, we need to get rid of 2 things. Which one first? The 3 and the negative 2. Which one first? The minus 2. So we'll add 2 to both sides. On the left side, those 2's cancel and everything else comes down. On the right side, negative 17 plus 2 is negative 15. Then we want to get rid of the 3 by dividing by 3. So we do that on both sides. 3's cancel, leaves the square root of 2e minus 1. On the right side, negative 15 divided by 3 is negative 5. Then we need to get rid of the square by squaring it. So we'll square the left side to get rid of the square. We'll square the right side because we did it on the left side. When the squares cancel, we get 2e minus 1 equals 25. Negative 5 times negative 5 is positive 25. Then we need to get rid of the minus 1 by adding 1. So we get 2e equals 26. And then we divide by 2, and we get e equals 13. All right, so now we want to check our answer. So we're going to take this 13 here, and we're going to plug it in where we see the e here. Everything else is going to be the same. So we've got 3 square root of 2 times 13 minus 1. minus 2 equals negative 17. Alright, so now we're not trying to get the square root by itself, we're not trying to get a variable by itself, we just need to simplify here. So when we simplify, the right side is going to stay negative 17, we just want to see if we get the same thing on the left. So inside of the parentheses, we want to multiply first. What's 2 times 13? 26, okay, so we get 3 times the square root of 26 minus 1, and then we've got our minus 2 on the outside. And then still inside of the square root, what's 26 minus 1? 25. And then minus 2. Alright, then what's the square root of 25? 5. So we get 3 times 5 minus 2. And what's 3 times 5? 15. So we get 15 minus 2, which is 13. So is this the solution to it? It's tempting to say yes because this 13 matches the answer we had here, right? But is that what we're trying to match up? No, we're trying to make sure the left side and the right side are the same. Is 13 the same as negative 17? No, those are not the same, so 13 is not a solution to this. Just like the one we had in the opener, this one actually does not have a solution. And again, the reason it doesn't have a solution is because we can't take the square root of a number here in this step and get a negative answer. When you take a square root, when you're taking a square root, the answer is going to be positive. So since there's no solution to this, I'm going to write what? No solution. All right, so just find space in there somewhere and write in no solution. And that is your answer. There's nothing that we can plug in for E here that is going to make this equation true. All right, last one. This one's a little different. What's different about this equation? It has 2 different variables in it, right? It has an x and a y in it. But you'll notice that the solution that we got has an x and a y. So this is not 2 different answers, but it's one answer for this equation. It's one solution. So we want to check to see if this is a correct solution for this equation. All right, so what do you think we need to do here? Even though we have 2 different variables, what are we going to do? We're still going to substitute just like we did before. But we need to be careful here. We're not going to put a 5 anywhere we see a variable over here. We're just going to put the 5 where the x is. Exactly. So when I'm doing my substitution, the 3 is going to stay the same, and then I'm going to replace the x with a 5. And then when I get to the y, I'm going to replace that with a 4. So I'm doing my substitution here. I'm just substituting 2 different values. I'm substituting 5s wherever there's an x. I'm substituting 4s wherever there is a y. Once I do that, now I just want to simplify. So I'm going to separate my 2 sides. I want to make sure that the left side is equal to 7 because 7 is going to be what we have on the right side. So on the left side, let's do our multiplication first. What's 3 times 5? 15. Minus 2 times 4?
8.
8. And then what's 15 minus 8?
7.
7. So is this a solution?
Yes.
Yes. So the only difference between this problem and the other ones we've done is we have 2 different variables, but we just plug in the different values for those variables in their corresponding places. And then we simplify just like we normally do. It actually turns out that equations like this that have 2 different variables, they have more than one solution. This particular equation here has infinitely many solutions. You could plug in any number you want for x and then find a y value that's also going to work. So this is just one solution out of many possible solutions, but it is a solution, so we put a check mark next to it. Just like the other ones, if these 2 did not match up, then we would put an X through it because this would not be a solution.